Greetings, ladies and gentlemen. I welcome you all to our today's lecture. In today's lecture, we shall be talking about standard continuous distributions. In our previous lectures, we have talked about discrete distributions, but today we shall be focusing at what we call the continuous distributions. And out of these distributions, normal distribution is one of the very important distributions. So we shall study some of its characteristics, importance, some applications of this same distribution. So let us look at normal distribution. A normal distribution is a continuous distribution. And we can define it as, so we shall be saying that a continuous random variable x is said to follow a normal distribution if it has got a PDF that is given by this expression. So you have your phi of x, which is equal to 1 out of sigma, which is representing the standard deviation, then multiplied by the square root of 2 pi, then e to the power of negative half x minus mu over standard deviation squared. And x takes up all the values from negative infinity to infinity, for which sigma is greater than 0. So if you have a random variable that has got a PDF which is given by this, then we shall be saying it is following a normal distribution. So we need to recall some of the few parameters here. One, mu will be representing mean, and sigma squared will be representing variance, meaning that sigma alone will be representing standard deviation. So these two parameters, mean and variance, will be the parameters for the variable that follows a normal distribution. So we shall be defining this, or we shall be reading this as x follows a normal distribution with the parameters mu and variance, which is sigma squared. So if we have this, then this implies that your variable is following a normal distribution, but with the parameters mean and variance. So from there, we can say that if x follows a normal distribution with mean and standard and the variance, then if you let, for example, z to be x minus mu divided by standard deviation, then we shall be saying that z is a standard normal variate. And if it is a standard normal variate, it will also be having the parameters 0 and 1. How? Because when we get the expectation of z, or the mean of z, it will be same as taking the mean. It will be same as having the mean of z. But of course, we can easily see that the mean of z will be same as taking the expectation of z. Your z is x minus mu divided by standard deviation. So if you have x minus mu over standard deviation, you can split this to be x over standard deviation minus mu upon standard deviation. So when you take e of x upon standard deviation minus mu over standard deviation, then you will have e of x over that minus e of mu upon rho. So remember, this is now a constant, only x is the variable. So it means you will have 1 upon rho expectation of x, but expectation again, that one has no impact because mu and this one are not variables. So it means we shall remain with mu upon standard deviation. So this is mu again, so you have mu upon standard deviation minus the same mu upon the sigma, so which will give you a 0, meaning that e of z will be same as 0. And likewise, we shall do the same for the variance, meaning you are having variance of x minus mu upon sigma, which is same as, so you can split this same expression. When you split it, it will be x upon sigma minus mu upon sigma, and from there, then x is the only variable, this is a constant. So if we recall from some of the properties of variance, if you have variance of x, for example, x divided by a constant a minus any other constant, then only this will be affected, but this one must come out as a square. So 1 over a squared variance of x. So that is what you get. Or else you can remember from the case that if you have a variance of ax plus b, that this is same as a squared variance of x from the properties of variance. So we can easily write this one as this, which also gives us variance of x. We have seen variance of x is same as sigma squared, meaning 1 upon sigma squared times sigma squared will give us 1. So z equaling to x minus mu upon sigma will be a standard normal variate that has got the parameters 0 and 1. Having obtained the expectation of z and variance of z, for which your z is x minus mu upon sigma, then we can now conclude and say that actually z follows a normal distribution with parameters 0 and 1, where 0 is representing the mean and 1 is representing what we call the variance. So we have got some of the situations where normal distribution occurs. So for example, in physical measurements, in areas such as rainfall studies, when you are looking at meteorological experiments, and also in errors in scientific measurements. Let us look at the curve, the normal curve. This one here is the normal curve. We have already seen the expression for phi of x, and this curve here is what we call the normal curve. So this normal curve from the normal curve, we can come up with some of the characteristics of normal distribution, and they are: 1, the graph of normal distribution, which is the normal curve, is bell-shaped, as we have seen, is bell-shaped. Then the normal curve is symmetric about a vertical line where x is equal to mu. Then the mean, median, and mode of normal distribution, they all coincide at the maximum value of the function. That is, they occur at the point where x is equal to mu. Then, from there, we shall be able to as well say that the curve never touches the x-axis. That is, it is asymptotic to the x-axis. So all those are some of the features from the curve that we have seen. Then also, our phi of x, being the probability, can never be negative. And in other words, no portion of the curve lies below the x-axis. And lastly, since the total area under the normal curve is 1, then it means that the area of the normal curve from x equaling to negative infinity to x equaling to mu is a half. Then, and also from x equaling to m to x equaling to infinity is also a half. So that is from x equaling to mu. So from x equaling to mu, from x equaling to mu to x equaling to positive infinity is also a half, meaning it is divided into two portions. From mu to negative infinity is 0.5, from mu to positive infinity is also a half. So from there we shall talk about the area under the normal curve. So the area under the normal curve is used to obtain what we call the probabilities. And some of these probabilities are, you have a probability of A less than X less than A, and this one here is this that we are looking at. So when you are having your curve like this one here, we can use it to obtain the probabilities. So we have seen that if this is your mu, this is your line which is representing mu, then from this point, from negative infinity up to this given point, from here the whole of this is representing a portion of 0.5 as we have seen, and the whole of this is representing also 0.5 as we have seen from the properties. Now it means that if you need the area P of A less than X less than B, you need this probability here, which is between A and B. You can easily obtain it from the normal curve, but we shall see how best we can obtain that. So let us now talk about how to obtain probabilities. How do we obtain probabilities? So we shall be saying the values of the normal distribution are first standardized using Z, which is equal to X minus mu upon standard deviation. Meaning that if you are dealing with a random variable X and you are looking for the probability of X1 less than X less than X2, then you first standardize this. And you standardize this by subtracting mu, then you divide by standard deviation. Meaning we can standardize this by having X1 minus mu upon standard deviation less than X minus mu upon standard deviation less than X2 minus mu upon standard deviation. So when you do this, you will be standardizing. So this is probability of X1 minus mu upon this. If this is Z1 from here, then we can have Z1 less than Z less than Z2. So from here, you have standardized your X. So which means now you will be dealing with this to get the probability. So you deal with the standardized expression to get the probability of X1 less than X less than X2. So after standardizing, then we need to look at how to read the cumulative normal distribution table. So we shall now consider how best we can get the probabilities for any values which are between 0 and any Z value. So we shall be saying that probabilities are given in the table for all positive values of Z. So if you are interested in the probability of 0 less or equal to Z less or equal to Z1, you can easily obtain this by simply reading from your table the probability of Z1. Because here you are considering from our normal curve. You are considering, for example, a probability which is between 0 and Z1. So if this is your 0 and Z1 is a point at this given point, then how do you easily get this probability? So you will simply go to your table and read the value of Z1. So if you are looking for this probability from 0 to Z1, then that probability of 0 less Z less than or equal to Z1 will simply be same as taking the probability of Z1. In other words, if you need the probability, for example, of 0 less than z less than 2, this one here is same as simply reading. This one here means table reading of 2. So you go into your table and read the value that corresponds to 2. And we can easily get that one from the table. So let us refer to the table. Here we need the table reading of 2. So 2 is the z value. So you will come in this column. We are using cumulative normal distribution table. So if this is your table, this is z. So in this one we are looking for, you are looking for the value where, because we are looking at probability of 0 less than z less than 2. And we are saying that this one here is same as simply taking the table value reading of 2. So you look at this, where do we have 2? So in the z value, you move until you are able to get a 2 in the z value. So 2 will be at this point here. So this is 2, but this is given as 2.0. So this first column here is representing the values of 0. So this is 0, meaning that this 2 is like 2.00. So you will take the value in the first column because we need 2. So we shall take the value in the first column where there is 0. So 2.0, then the first column is for 0. In other words, you are simply taking the value for 2.00. 2.0 is this value. Then another 0 is this column. This is the column for 0, the column for 1, the column for 2, the column for 3. So 2.0, then 0 is this value. It is the value which is 0.4772. So that is the value for 2.00. Meaning if you are looking for this value, you simply, which is between 0 and z2, you simply take the table reading of this value, which is 2. So you come to your table and take that value. So clearly we have the table reading of 2 as 0.4772, and we have seen how best we can obtain that. So probabilities of 0 less than z less than z of p can easily be obtained from the table. So if you have 0 less than z less than any positive value here, then you can easily obtain that from the table by simply reading the value that corresponds to z of p here. So let us look at these other values here. We need the probability of 0 less than z less than 1. And as we have seen, if you are looking for this probability here, you simply go to your table and take the reading of 1. If you are looking at the probability of p, which is 0 less than z less than 2.25, you simply go to your table and take the value of this. Then if you are interested in the probability of 0 less than z less than 0.024, you simply go to your table and take the reading for this. So let us look at how best we can obtain these probabilities from the table. We need the table reading of 1, the table reading of 2.25, and the table reading of 0.024. So from our table, we can easily obtain that. So let us read from the table to get the answer there. So let us obtain the table reading of 1. So we shall come to our table, and we read 1. 1, we look for the z value where we have 1. So we shall look at this value. 1 is here. So 1.0, but it is for 1. So it means we shall be taking 1.00. So that value will be 0. This value here is the value that we shall consider 0.3413. So from here we have that value as 0.3413. So that is the value we obtain. Then 2.25, the table reading of 2.25. 2.25, we shall look for 2.25. That is what we are interested in. So 2.25, we shall first of all look in the column for Z. So in the column for Z, we have no 2.25. We need 2.25. But when you look here, we can only get 2.2. This value here is the value we can easily get, 2.2. So which means that we need 2.2, then 5. So we shall come here, we look for 5. Because this the first columns here, these first columns are corresponding at what we call the 2 decimal place. So it means you can easily get a number which is up to 2 decimal places. For example, 2.25, the values are the values in this space that we are having here. So if you want 1.1, it means you will take 1.00. If you want a value like 2.25, you can easily get it. But if there is a third decimal point, or a third decimal value, or a value in the third decimal place, then you get that additional value from this these columns here where we have add. So we need 2.25. 2.25, we shall first of all get 2.2. Then after getting 2.2, we shall come where there is a 5. Where there is a 5, and in that line that corresponds to 2. This line here, where we have a 5. A 5 is at this given point. So this will be 2.25. That is 4878. When you are taking this value, you take it as 0 point. So these are point. The first value is 0 point, 0 point. So it means this value here will be 0.4878. 0.4878. So that will be the value, and that is the value we are having here. Then we can now say find the following probabilities. So we can easily obtain the probability of 1.252. So the probability of 0 less than z less than 1.252 can also be easily obtained from the table, and let us see how best we can obtain that. We are interested in getting the table reading of 1.252. As I said, the first point, that is 1.2. 1.2, the value to 1 decimal place can be easily obtained from here. So that is 1.2. So we need 1.2. 1.2 is here. This is 1.2. Then 5. Then look for 5 here. 5 that corresponds to 1.2. So 1.2 we shall move like that. Then we shall move, and that is 0.3944. Then from there, we need to add there the next value, or the value in the third decimal place should be obtained from the additional columns. So you will move like that in the additional columns where you have the value 2. So 2 is here. So in this column for 2, that corresponds with this value. So we shall move like that. This is a 5. We have obtained that. Then in the column for 2, we have a 4. This is a 4. So you will now have a 4. So this 4 will be written starting from the first decimal point, or the same first decimal place. So others will become zeros. So you add this. So this will be 8. This will be 4, 9, 3, then 0. So this becomes your value. That is 0.3948. So clearly we shall have the same value here. So how do you obtain the probabilities, especially if you are having what we call the negative value for z, because we have been focusing at only positive values. So what we have seen so far is that when we are reading probability of 0 less than z less than any value of z which is a positive value, you simply take the table reading of this value z1. That is what we have seen. So long as you have from 0 to z1 and it lies in the positive part of the curve. So what we have been looking at is when we need the value from here up to this given point. If we need this value, you simply go to your table and take the reading, if this is your z1, and simply take the reading of that z1. But let us look at the case if you are interested in the negative value. For example, you need probability of negative z1 less than z less than 0. So for this case, we shall be having what we call the symmetry. We shall use the symmetry. So by symmetry, we shall be saying that this value from here up to this given point is the same value from here up to this given point. If this is z1, this is negative z1, meaning that if, for example, this is negative 1.2, and from here up to here is 1.2, so this probability here will be same as the probability from here up to this given point, meaning that instead of looking at the negative z values in the table, since we are dealing with positive z values, so we shall first of all eliminate this negative here. And how do we do that? We use what we call the properties of symmetry. And that we shall be saying that by symmetry, if you have negative z1 less than z less than 0, by symmetry it is same as the probability of 0 less than z less than z1. Because if you need the value from in this region here, this value here is the same value as from 0 to z1. So instead of looking at this, we shall be looking at this value. Because we already know how to take the reading of this value, so you simply take the table reading of z1. So meaning by symmetry, this value is same as this. The probability is the same. So instead of focusing at negative z1 less than z less than 0, we shall be taking the probability of 0 less than z less than z1, and that is by symmetry. And we already know that if we have this, it is same as taking the table reading of z1. So that is what we are saying here. Probability of negative z1 is less than z less than 0 is the same as the probability of 0 less than or equal to z less than or equal to this should be z1 less than or equal to z1. So meaning that if you have this, you can write this, and this one here is same as table reading of z1, and we obtain that by what we call by the property of symmetry. So likewise, we can say that if you need the probability of negative 0.5 less than z less than 0, you will simply take the probability of 0 less than z less than 0.5. And you know that this is same as taking the table reading of 0.5. So what is the table reading of 0.5? Go to your table and read this value, 0.5. So if you go back to the table, 0.5 is this value. So the 0.50 is this value here, 0.1915. So that is the value that we have here, 0.1915. And that is the value that we use instead of using what we call the negative value. Because by symmetry, this region here, the probability obtained from 0 to negative z1 is the same as the probability from 0 to z1 by what we call symmetry. If you are now looking at the case for which you want the probability for any value that is less than any positive value of z. For example, probability of z less than z1. So how do we obtain that? So probability of z less than z1 will be same as 0.5 plus probability of 0 less or equal to z less or equal to z1, because we can easily read this one from the table. So that's why we must manipulate this to be in this form. But how do we get that? If you go back to your curve, for example, if we have our curve like that, so this is where we have our 0, and this is where we have our z1, for example. So if this is our z1, we need the probability of z less than z1. So this probability here, we are considering region where z is less than z1. So this is z. So where do we have z less than this value? Is the whole of this region. Is the whole of this region. But as we said, that this value from here up to there is 0.5. The whole of this value, the probability of this, the value from negative infinity to 0, to this given point where mu is 0, this value here will be 0.5. This value here is 0.5. So you did the probability from negative infinity up to z1. So this, it means it is same as from here up to this given point, which is 0.5. Then you add from here up to this given point, which is same as the probability of 0 less than or equal to z less than or equal to z1. So it means if you need the probability of z less than z1, you simply get 0.5, because we already know from here up to where mu is 0 is 0.5. You add there the probability of 0 less than or equal to z less than or equal to z1, and this is same as 0.5 plus this one here we have seen is simply same as taking the table reading of z1. So it means if you are looking for the probability of z less than any positive value of z1, then you simply get 0.5 plus the table reading of z1. So that is what we get. Then the same expression is the same as when you are dealing with the probability of z greater than negative z1. In probabilities, or if you recall very well, when you are dealing with what we call inequalities, if this is a negative, is a greater sign, and you divide through, if you recall that expression, if you are having negative x maybe greater than 2, if you need the value of x, then if you divide through by negative 1 here, for example, your x, because you are dividing by negative, your sign must change here and you have negative 2. So we use the same concept, though we shall not be dividing, but we use the same concept here. So instead, if you have p of z greater than negative z1, if you have this value here, this value will be same as, to remove this negative value, simply change this inequality sign. So it means you will have z less than z1, meaning that instead of taking the value for z greater than negative z1, as I said, we shall be only considering positive values of z. So it is better to look at how best you can eliminate the negative sign. And if you have such an expression where p of z is greater than negative z1, you simply change the sign of the inequality. So it means this is equivalent or is equal to this, is equal to probability of z less than z1. And as we have seen, if it is less than, it becomes 0.5 plus the table reading of z1. So how does that one work? So here you have negative z1, but you need the region where z is greater than z1. Remember, this is our z. So which region is greater than negative z1? Is this region here. The whole of this region is greater than negative z1. So this region here, by symmetry, is the same region as when you are considering if this is negative z1, if I have the same value but a positive value z1 here. It means by symmetry, if I'm considering the whole of this region here, by symmetry it will be the same region as someone who has considered the whole region here, the whole of this, because this is your z1, the same value for the value that you considered for negative z1. So this region, this probability here of getting from this is the probability of z less than z1, and this is the probability of z greater than negative z1. The two probabilities will be the same because by symmetry these two regions will be the same. So we need to take note of that. Let us now look at some few examples. Now, if you need to find the probability for which z is less than 2, you need the probability for which z is less than 2. So if it means that if this is your z equaling 2, for example, you are interested in the probability, which is this probability. But as we said, this normal curve is divided into two. This part is 0.5, this part is 0.5, starting from where 0 is. So it means if I need the whole of this region, I will get this part already, I know it is 0.5. Then I add there the probability of 0 less or equal to z less or equal to 2, which is from here to there. So which means if I'm dealing with a less than, simply know that if you have p of z less than 2, it will always be 0.5. No, that one is addition. If it is a less than, that will be 0.5 plus the table reading of 2. But that one comes from this expression here. Because this is 0.5 plus here, as we saw at the beginning, if you have 0 less, z less, you obtain that one direct from the table. So that's why we say the table reading of 2. So it means if I need z less than 2, I will be getting 0.5 plus the table reading of 2. So what is the table reading of 2? We shall check the table reading of 2. The table reading of 2, we shall come to where z is equal to 2. So it means we are taking 2.00, that first column there for 0. So 2.00 will be this value, 0.4772. 0.4772. So we shall go back and substitute 0.4772 where there is table reading of 2, and the value obtained will be the value for p of z less than 2. So next we need the probability. We need the probability of z greater than negative 1.377. As I said, don't even waste time looking at what this one is equaling to. So simply look at this. If it is a minus, change the inequality here. Then it becomes p of z less than. If it is greater than, it becomes less than, so long as there is a minus. Then put the positive part, 1.377. So it means you are looking for probability of this. Because in our table we are looking at positive values of z. So if you have a minus, first change the sign there. And if you change the sign of the inequality, then and you have p of z less than 1 point, then you can easily obtain this. If it is less than, it becomes 0.5 plus the table reading of 1.377. And from there, it means you have 0.5 plus what is the table reading of this. So you will go to your table, you look for 1.3 where there is 7. 1.3 where there is 7. 1.3 is here, And where is 7? 1.3 is here, and we look for 7. 7 is here. 4147. So it means you have 0.4147. But that is for 1.37. So you need an additional value from additional columns where there is 7. So 1.3 is there. So we have to go up to where there is a 7. A 7 will give us 11. So that is the 11 we are talking about. So if it is like that, as I said, you have 0.4147, but you are adding the other additional column, we got 11. So put 11 there, 0.0, then add. This becomes 514, then 0. So this one here becomes the total value that we obtain. So this is the total value that we have obtained, but there is a 0.5. So add there the 0.5, and that will be the total value for P of Z less than negative 1.377. So if you are having P of Z greater than, then simply change the sign of the inequality. Then if it becomes P of Z less than, if it is less than and it is like this, simply know if for less than we get 0.5 plus the table reading. Then we shall also look at other different ways of how it is handled, especially if it is greater than. So next we look at where we are dealing with greater than any positive value of Z. So how do we handle that? If you are interested in the probability of Z greater than Z1, then we shall be interested in this part here. We shall be interested in this part. We need the part, the whole of this is Z. So which part is greater than Z1? If this is Z1 here, then the part that is greater than Z1 is this. Okay, but we know from here up to this given point, from here up to this given point is 0.5. And if I need the value from here up to this given point here, it means I will get 0.5. I subtract the value from here to here, which I can easily get. Because if I can easily get this value, and I need from here up to here, and I know the whole of this is 0.5, so it means I will get 0.5. I subtract the probability from this given point to this, which is 0 less than or equal to Z less than or equal to Z1, because this value can easily be obtained from the table. So it means I can have this as 0.5 minus the table reading of Z1. So that is what we obtain. And that is the probability of Z greater than Z1. If I need this probability from here to here, and I know the whole probability of this is 0.5, then, and I know that this probability from here up to here I can easily get it, then I can easily obtain the remaining probability. By getting the whole of it, which is 0.5, I subtract the table reading of Z1. This value is what we obtain from the tables. So it is better to first express what you have in terms of the value that can be easily read from your table. So that's why we are doing all this. So probability of Z greater than Z1 is same as this. Similarly, if you are also having the probability for which Z, if in any case you have that probability that Z is less than negative Z1, as I said, if this becomes a minus and you are having Z and Z1 and this is a minus value, simply change the inequality sign here. So it means this one here will be same as Z greater than Z1. So instead of dealing with negative Z1, we shall be dealing with this expression. So P of Z less than negative Z1 is same as P of Z greater than Z1. And as we have manipulated P of Z greater than Z1 is 0.5 minus the table reading of Z1. So that is what we obtain. But this can be easily seen from what we call symmetry. So by symmetry properties, we can easily write that. So by symmetry, we shall have that this, because we are interested in the probability of Z, which is less than negative Z1. That is the probability we are talking about, this one here. So this same probability here is the same probability if you have Z1 here, if you have Z1 here, and if this is Z1, then it means this same probability here, which is greater than Z1, is the same probability as this one here. So that's why we say by symmetry, the two are the same. So let us look at some examples as well. So the first example, we need to look at the probability of Z greater than 0.85. So how do we obtain that? So we shall simply say this one here, Z greater than 0.5, is same as 0.5 minus the table reading of this. So if it is greater, you get 0.5 minus the table reading of this. If it is less than, you get 0.5 plus. So plus is for less than. Then if it is greater, then you use subtraction. I hope you are taking the difference between the two expressions. We shall majorly be using the two expressions, especially for less than and greater than. So you need not to confuse the two. So probability of Z greater than 0.85 will be same as 0.5 minus the table reading of 0.85. So you can easily obtain the table reading of 0.85. So you will go to your table, look for 0.85. So 0.8 is here, then you look for 5. So the 5 will be, this is 0.8, so 5 will be at this given point, 3023. So 3023 will be our value. So we get 0.5 minus 0.3023, and the value you get will be the value for probability of Z greater than 0.85. If you are interested in the probability, of Z less than negative 0.25, as we said, this is same as probability of Z. Because of the negative, the sign of the inequality will change, 0.25. You already know how to read this value. So from the table, which means this, we can as well write it as 0.5 minus the table reading of 0.25. So go to your table and take the reading of 0.25. 0.2 is here, then 5 is here, 0.0948. 0.09, 0.2, then we need 5, 0.0987. So we need 87 there. So 0.25 will be 0.0987. So that is the value you obtain for 0.25. So you go to 0.2, then look for where there is a 5. So that is the value, 0.0987. And that is the value you substitute here and subtract, and what you get will be your answer. We have so far seen two cases for less than any positive value of Z and greater than any positive value of Z. We have seen the two differences. Now let us look at some other important expressions. So far we have already seen how to deal with such numbers. Probability of Z less than negative 2. You simply change the inequality sign, and it becomes probability of z greater than 2. If it is greater, then it becomes 0.5 minus the table reading of 2. So that is basically what we said. And let us look at some other important results, especially for the case when you are having you are looking for the probability in which the value is between any two positive values or any two negative values or any negative value and a positive value. So let us look at the case where we have between two z values on the same side of the mean. So if you are having an expression where you are looking at the probability of z1 less than z less than z2, then we are saying this is same as the probability of 0 less than z less than z2 minus the probability of 0 less than z less than z2. That can be easily obtained because if you are looking at your curve here, if we look at our curve back here, you realize if you are interested in this probability here, you are interested in getting this probability. So if you are interested in getting this probability, that is probability of z1 less than z less than z2, it will be same as, so if I need this, first of all, I can easily get from here up to there, and I can easily get this probability from 0 to z1 and from 0 to z2. So what will be this probability here? This probability is same as from 0 to z2 minus from 0 to z1. So that is same as probability of 0 less than z less than z2 minus probability of 0 less than z less than z1. So I can easily get this probability by doing this. But we might not need to go through all this process here. So if I have this one here, I will always treat it in this way. So this is probability of z1 less than z less than z2. So what I would like you to be doing is, when you have such expression and you have less than values, so what you will do is look at this value. This value is z2. So you will say probability of, this is probability of z less than z2 minus the probability of z less than z1. So you get the value of this one here, the probability of z less than this, the value which is in this position, then subtract the value for this. And this will be same as we have seen. If you are dealing with less than, it is same as 0.5 plus the table reading of z2. This one here, this is minus of, this is also less than, this is 0.5 plus the table reading of z1. So this will be giving you 0.5 minus 0.5 will cancel out, you remain with probability, the table reading of z2 minus the table reading of z1. So that is what you will obtain, which is same as this expression. This is the table reading of z2 minus the table reading of z1. So using this manipulation here, we can do all other values, whether this is a minus, this is a minus, this is a positive, this is a minus. You can easily get the expression for all the values if you treat it in this way. P of z less than z2 minus P of z less than z1. So get the value in this position, z less than z2, then subtract the value of z less than z1. So when you do this, you'll be able to manipulate it very well. And this same expression is this expression. And that is what you obtain if you use the curve. It means you are getting this probability minus this probability. From here up to here is the table reading of z2. From here up to here is the table reading of z1. and you need the value which is here in between, so you will subtract. So that is how we can easily manipulate that. So let's get back to this one here. We were looking at probability between two z values on the same side of the mean, and that is what we obtain. And likewise, when we are looking at this one here, I want us to use the same manipulation I told you about. If you are looking at probability of negative z4 less than z less than negative z3, so simply treat this one as probability of z less than negative z3 minus probability of z less than negative z4. This is what we are having. So let us see whether we shall get the same expression here. So this one here, by the fact that this is a minus, we shall change this to be greater now, z3. Minus, this will be p of z, this is also a minus, so it becomes greater, z4. So this will be same as, if it is greater, it means it is 0.5 minus the table reading of z3, if it is greater. If it is less, then this becomes addition. Then minus, this one here is also greater, so it is 0.5 minus the table reading of z4. We looked at that when we are looking at probability of z less than z1, how we can treat it, and probability of z greater than z1. So we treat it in that way. So this will be 0.5 minus 0.5 shall cancel. You remain with table reading of z3. This is minus minus. This is a plus table reading of z4. So this will be same as table reading of z4 minus the table reading of z3. And that is the same expression that you would have there. So you might not need to cram that if you are having probability of negative z4 less than z less than negative z3 will be probability of 0 less than z less than z4 minus the probability of 0 less than z less than z3. If you draw your table, you can easily, if you draw your curve, you can easily get this one here from your curve. If you need the probability between negative z4 and negative z3, so you can easily get this expression. But this expression can easily as well be manipulated from what we have already seen. So the moment you have the probability of a less than z less than b, treat this as probability of z less than this value, then minus probability of z less than this value. Okay, then from there, then manipulate. If it is less, then it means you will have 0.5 plus table reading of b, minus if it is less, it means you have 0.5 plus the table reading of a, like that. So these values can easily be obtained, and you have your expression manipulated. The negative or the greater than will come in, especially if you have the negatives. So the greater than will be in position to come. But even if it is a minus here, it is a minus here, it is less than, then treat it in this same way. Then this will be a minus, this will also be a minus. Then manipulate it, and you will be able to get this answer very easily. So from that, that is how best we can obtain that. Then let us look at now another expression when we have between two z values on the opposite side of the mean. So opposite side of the mean. For example, if you have something like this, I want us to maintain the same way. You have probability of negative z3 less than z less than z1. And as I said, this will be probability of z less than z1 minus the probability of z less than, this is now negative z3, like that. So if you have this, from this expression, using the same way we have been manipulating these ones here, we can as well manipulate this and we get the same expression here. So simply get probability of z less than z1 then minus the probability of z less than negative z3, the way it is here. So from our manipulation, this is 0.5 plus, if it is less than, table reading of z1 minus, then this one here, before we do anything, we need to change. This is a minus, so this will be greater z3. So meaning we shall have 0.5 plus table reading of z1 minus, this is greater, so it becomes 0.5 minus the table reading of z3. So that is what we have. So 0.5 and this one, because this is 0.5 minus 0.5 will go away, so you remain with table reading of z1 minus minus will be plus the table reading of z3. So clearly you can see that is the same expression you will get here. So this is a method which is easier for you to easily manipulate the expressions, whether they are containing minuses or not. So that one you can easily obtain. Then let us look at for the case when you are having magnitude. So if you are dealing with magnitude, it is also easier. It is a matter of understanding what magnitude means. If you are looking at probability of magnitude of z less than z1, if it is less, then this expression will be same as probability magnitude. It means it is same as positive and minus values of z. So it means you will have negative z less than z less than, this is z1, so this will be minus z1 positive. But we know how to manipulate this. So using our normal way of manipulating these values here, it means we can have this expression as well manipulated. So let us see how we can manipulate that. So it means you are dealing with probability of negative z1 less than z less than z1. So this, as I said, it will be p of z less than z1 minus p of z less than negative z1. So here you must consider less. So whatever value is here, then you should be able to deal with that. So this will be probability of z less than z1 minus probability of z. This is a minus here, so the sign will change, z1. So by definition, this is 0.5. If it is less than, it becomes a plus the table reading of this 0.5 plus. If it is greater, it means it will be 0.5 minus the table reading of z1. So what do we get finally? This is 0.5, 0.5. This is a minus, so 0.5 will go away. Remain with table reading of z1 plus, this is minus minus, plus table reading of z1. And this will finally give you 2 table readings of z1. So that is what we get if you have this expression here. The most important thing, magnitude of z less than z1 is same as this expression, which this expression can be manipulated to give you this. So I hope that one is now clear. Then lastly, if you are having probability of magnitude of z greater than z1, so this will we shall first of all create the less sign. So if it is greater, z greater than, and this is the magnitude, so you must treat it as 1 minus probability of magnitude of z less than z1. You are looking for the probability of magnitude of z greater than z1. So it can be written as this, as 1 minus the probability of magnitude of z less than z1, which this one here we have already seen as the 2 times the table reading of z. So you will have 1 minus 2 times the table reading of z. So that is the expression we are having here, z1. So that is what we obtain. So that is how we obtain different z values, and you should be able now to use the same knowledge now to deal with different numbers. Let us now look at some examples and apply what we have so far covered. So in our first example, we shall look at the probability of 1.5 less than z less than 1.88. As I said, we need to first manipulate that given expression to be of that form, that is p of z less than 1.88, this one here, minus p of z less than 1.5, this one here. So from there, we shall now apply. We know that if it is less than, then it becomes plus. So it becomes 0.5 plus the table reading of 1.88. If it is less also here, then it becomes a plus. So it means the 0.5 will cancel out, and we shall remain with the table reading of 1.88 minus the table reading of 1.5. So we shall go to our table and read these values here. So from the table we need 1.88. So we look for 1.8. 1.8 is here, then we look for 8. So 8 is here, 4699. So we shall have 0.4699. So that will be the table reading of 1.88. So that is 0.4699. Then you will subtract the table reading of 1.5. So we need to get the table reading of 1.5. So 1.5 is here. 1.5 of 0 is 0.4332. 0.4332. So you will come here and substitute it. 0.4332. Then compute that one there, and that will be your answer. So next, let us talk about p of negative 1.4 less than z less than negative 0.6. As we said, first put it in this form where you are having p of z less than this value here minus p of z less than this value you have here. Then manipulate it. So it means from here we need to first of all change the sign of the inequality here because of this minus. So in the next we shall have probability of z greater than 0.6 minus probability of z greater than 1.4. So from there we shall manipulate this. If it is greater, we use a minus. If it is less, we use a positive. So probability of z greater than 0.6 minus probability of z greater than 1.4. So it will be same as 0.5 minus the table reading of this, then minus 0.5 minus the table reading of 1.4. So on simplifying that, we shall be able to get the table reading of 1.4. When you simplify this will be a positive, this remains a minus. So we get the table reading of 1.4 minus table reading of 0.6. So go to your table again, read 1.4. So where is 1.4? 1.4, so we shall take 1.40. So that is 0.4192. 0.4192. That is 1.4. So that is the value we have here. Then the value of 0.6 is the value that we have. 0.6. 0.6, that is the value we have here. That is 2357. 0.22. Okay, we are looking at 0.6. 0.60. Okay, this is 0.2257. 0.2257, and that is the value. So simplify that, and that will be your answer. So we can as well get these values from the calculator especially the values to 2 decimal places. So if you are looking for the Z value to 2 decimal places, instead of using the table, you can use your calculator. However, you have to be very keen. Your answer must be to 4 decimal places. So whenever you need, for example, to get the table reading of 1.4, you express your calculator in standard deviation. So what you do, put the calculator in standard deviation. So when you put it in standard deviation, then you will press shift, then when you press shift, then 3, press shift, then 3, then after you will press number 2 where there is Q. So it will be Q, then into, so that will be in position 2. So press 2 and it will bring you Q. So when you press 2, it will bring you Q. So the Q is the table reading. So 1.4, press 1.4 and you will get your answer as 0.4. Your answer from the calculator will be 0.41924. So you express this to 4 decimal places. So this will remain 4192, which is this value. If you need the table reading of 0.6, do the same. So put your calculator in STD, then press shift, then after shift, then press 3, then after 3, press 2. Then take the Q. So Q is the value you are looking for. So 0.6, so put 0.6. In our next example, we shall talk about the example involving a magnitude. So let us look at this one here. So probability of magnitude of Z less than 1.75. As we have seen, by definition, if you have probability of magnitude of Z less than 1.75, you can write it as probability of negative 1.75 less than Z less than 1.75. Then now try to simplify it using the method we have been using. So you get probability, you will get probability of Z less than 1.75 minus the probability of Z less than negative 1.75. So that is what we obtain from there. Then from there it becomes easier, because from there you can now change this sign of inequality because of this minus. So this one changes to greater than. Then here you are still maintaining your less than sign. Then you know by definition of this, if it is less than, we add 0.5 plus the table reading of this, minus if it is greater, we subtract 0.5 minus the table reading of this expression. So that's what we are having there. And on simplifying, clearly we can see 0.5 will cancel, minus minus will give us a plus, so you remain with 2 times the table reading of 1.75. So go to your tables and get that value. So from the calculator, if we are to get it from the calculator using the same procedure, 1.75, we only get to a number which is up to 2 decimal places. The number with 3 decimal places, it is better to use the tables. So from there we can obtain, if you are to use the calculator, your value will be 0.45994. So you have to put it to 4 decimal places. So when you put it to 4 decimal places, you will get that. So it means your value will be 0.4599. But you can as well get it from the tables, because you need a value 1.7. 1.7 is here. Then 5. We look for 5. 5 is here. So we can easily see 4599. So that is 0.4599. That is the same value there. So simply multiply and get your answer there. So our answer will be 0.9198. So that is what we obtain. If it is greater than, like for this case, as we said, if it is magnitude of z, but if it is z alone, it becomes simpler, because if it is z alone, probability of z greater than 1.433, for example, it becomes easier now, because you would simply get this, because this can simply be 0.5 minus the table reading of this value. But this is a magnitude, so you must first of all remove the magnitude sign, and at the same time you have to first of course deal with the equivalent expression of this, which is 1 minus the probability of this, probability of magnitude of z less than 1.433. That is what we get. But we can easily manipulate this. This is same as negative z less than, this is same as negative 1.433 less than z less than positive value 1433. So which we can again easily manipulate. So we shall have we shall have 1 minus probability of this. This one here is the definition for this. From there, which will give us 1 minus. Now, we are manipulating this one alone. We are manipulating this. This expression can be manipulated as probability of z less than 1.433 minus probability of z less than negative 1.433, using the same procedures we have done so far. Then from there, we shall have, from this given point, we shall have 1 minus that. So from here, we change this inequality sign to be greater than because of a minus. If we are to remove a minus, make sure you change the sign here. The inequality sign should change. So from there, interpret by interpretation of this. This is greater, this is less than, so it becomes a plus. This is greater, it becomes a minus. Okay, so we are manipulating that expression, and when you try to manipulate that, where there is greater, z greater than 1.44, we already know how to deal with it. Z less than 1 point, we already know how to deal with it. This is 0.5 plus because it is less than, and if it is greater than 0.5 minus. Then try to simplify that expression. And when you simplify this, it means this will be a plus, so you will have that. So that is 2 times the table reading of that. So get the table reading of 1.433. So 1.433, as I said, from the calculator you might get the wrong answer. If you put it on the calculator, 1.433, you will get, from the calculator you will get 0.42407, which means it would be 4241 to 4 decimal places. But let us see from the tables. So when you look at 1.433, let us try to manipulate it from here. 1.433. So 1.433 is what we need from the tables. 1.43 is here. 1.4, then 3 is this. So that is 0.4, 1.43, 4236. So we are adding there 3 in the other additional column. 3 in the additional column is 4. So this will be 4000.0. So add that. This is 0. This is 4. This is 2. This is 4. This is 0. So you get 0.4240. 0.4240. So when you look at the value we got from the calculator, the value we got from the calculator was 0.4241, and the value we are getting from the table is 0.4240. So you can see there is a difference there. So you have to use the tables, especially if the value is having up to 3 decimal places. And even when you are using a calculator, you need to be careful, especially for the numbers to round off. On rounding off to 4 decimal places, you have to be keen to know how and when you are supposed to round off. So it means from there we shall be able to get as 1 minus 2. So this is the value we got direct, then this is the value from the additional table, and we should be able to get that answer there. So that is what we obtain for when we are dealing with such numbers. So next we can look at some more examples here. Let us look at the case where x follows a normal distribution of n, that is n into 325. If you recall very well, x follows a normal distribution. This one here is the mean, and what you have here is the variance. So it means, according to this, our mu is 300 and our standard and our variance is 25, meaning standard deviation is 5. Square root of the square root of 25, it will give us 5. So here we have 5. So mu is 300, standard deviation is 5. So if you are having this number p of x greater than 305, make sure you standardize first. So you have p of x minus mu upon standard deviation greater than 305 minus mu over standard deviation. So you standardize. So this will be same as p. This becomes z greater than 305 minus mu. Mu you have 300, then divided by 5. So it means you have p of z greater than 305 minus 3, that is 5 over 5. So you have p of z greater than 1. As we said, if it is greater, it means you have 0.5 minus the table reading of 1. You know how to obtain the table reading of 1? Simply substitute and get your answer. So that is how we manipulate that expression. So go to your table, look for 1.0, it becomes 0.3413. So this is the value that you will take. So let us go through that very fast. So standardize. After standardizing, get p of z, which is equal to that. So from there, we are first standardizing, and after standardizing, that is, you subtract mu, then divide by standard deviation. So do the same for x and do the same for this value. So that is what we shall get. So from there, we have p of z greater than that. As I said, this value here, mu is 300, and standard deviation squared, this rho squared here, sigma squared, same as 25, which means standard deviation is 5. So that's why we are using 305 here. So from there, we are having 0.5, because it is greater, so it becomes minus the table reading of 1, which table reading of 1 we have already seen. So go to 1. 1 is here, 0.03413. So that is 3413 that we have there. And the answer you obtain will be the probability. So from there, we can also look at, for the case if it is less, we do the same. First standardize, and you standardize by subtracting mu and dividing by standard deviation. What do we get there? So we shall be able to remain with 291 minus 300 divided by 5. we get negative 1.5. To deal with the negative, first make a positive value by changing the sign of the inequality, and that will be probability of z greater than 1.8. So do the same. If it is greater, then you get 0.5 minus the table reading of that, and we shall be able to get the answer. So try out these questions here. P of x less than 312, confirm if you get that answer. P of x greater than 288, confirm if you get that same answer there. So try out those numbers. Let us look at one more example. So our example next, we shall have we are told that the heads of students at a particular university follow a normal distribution with mean 150.3 centimeters and standard deviation 5 centimeters. We need to find the probability that a student picked at random from the university has height which is less than 153, more than 158, and between 150 to 158. Let us look at the example. If x becomes our random variable, it means x follows a normal distribution with mean 150.3 and variance which is 25. Variance is standard deviation squared. So you get 5 squared, then it gives you 25. So if we need the probability of x less than 153, we shall standardize. So when we standardize x, when we say x minus mu divided by standard deviation, we shall get z. So we do the same for 153, we subtract mu, we divide by standard deviation. So we shall have this. So from there, we shall have probability of z less than 0.54. From our definition, we can write this as 0.5 plus the table reading of 0.54. So go to your table and get the table reading of 0.54. 0.54. 0.5 is here, 4 is here, 20, 54. So that will be 0.5 plus 0.2054. So from there, we shall simplify that, and that will be our answer. Let us talk about P of x greater than 158. We shall do the same. P of x greater than 158, standardize. After standardizing, simplify your expression. 158 minus 150.3 divided by 5 will give us 1.54. After that, then get this one here. This is greater, so we shall subtract the table read 0.5 minus table reading of 1.54. So get the table reading of 1.54. 1.5 is here, 4 is here, 4382. So we shall have 4382. So 0.5 minus 0.4382. So from there, we shall be able to get our probability. Then the next, we need the value probability of 150 less than x less than 158. So we shall do the same, standardize first. If it is x, standardize first by subtracting. You standardize this by subtracting mu here, divided by standard deviation, subtract mu divided by standard deviation, subtract mu divided by standard deviation. So you will have this, x minus mu divided by standard deviation will be z. This value here will be this. So after standardizing, you will have negative 0.06 less than z less than 1.54. Then we can treat this as p of z less than this expression minus p of z less than this expression. That is what you have there. So from that given point, you treat this as this. It remains the same. Since we are not having a minus here, because of a minus, this sign must change to be a greater sign. So from there, we can now interpret this. If it is less, it becomes addition. If it is greater, it becomes subtraction. 0.5 plus the table reading of this minus 0.5 minus the table reading of that expression. So from there, we shall remain with the table reading of 1.54 plus the table reading of 0.06. Go to your table, obtain the values for 1.54 and 0.06. And that will be the answer. So from there, I will be able to leave you with some few questions here for you to try out. We have some trial questions here, and these are some of the numbers that you need to try on your own, and some answers are also given. So try these numbers out. So these are the questions to try and see if you are able to get the answers there. And that is basically where we shall start in our next lecture.
Yeah.